So hello there and welcome back. Today I want us to work on a new tutorial series. We'll be focusing on building an expression evaluator. Think of it like a subset of a scripting language that basically takes in some expressions, we evaluate them and give out the result and output. We'll be working primarily in C++, and this tool will be used in another project I've been working on called Mantis Base. If I go to GitHub, this is the project. What Mantis Base is all about is actually a lightweight backend as a service toolkit. So everything compiles down into a single binary. Once you run it, you can get a full backend with currently working on the real-time database and other aspects which are still missing. But so far, everything is already built in with auto-generated REST APIs, authentication, admin dashboard, file uploads, and other things. So as part of the whole execution, specifically when you're doing with authorization, we need to evaluate some scripts based on user instructions. And there are many solutions which are already there in the market to do this kind of service. But there are challenges depending on the use cases that we are focusing so much on. And so I thought it would be a good idea to kind of build one from scratch. And then once we are done with the whole tutorial series, we can now embed it into the project we've been working on. So if you want, you can also check out this project. Mantis Base is on my GitHub repo, which will be linked down in the description of this video. So the idea hereby is then you're given a string stream which contains instructions on maybe one or two things, and you need to evaluate the whole thing down to the resultant value, and then based on that value you determine if you can give access or not. So on a lower scale, think of it basically like a mathematical expression whereby you're given variables that you need to figure out their actual values and then do comparisons, maybe mathematical operations on them. And based on the resultant value, you now grant access or deny access. So what we should be working on today is to build the whole thing from a tokenizer, or people normally call it a Lexer. And out of a tokenizer, we'll be getting an array or a vector of tokens. And we'll be passing these tokens through what we call a parser. And the parser will generate for us an AST. AST is called the abstract syntax tree. And based on this abstract syntax tree, you can now pass it into a compiler, maybe to generate a binary output, or you can even pass it through an interpreter to be able to get a runtime evaluation. There are other things you can be able to do, like maybe code syntax highlighting and things like that once you have the AST. You can also do things like transpiling, basically converting from maybe the scripting we'll be working on into maybe generate a C++ or even a C code, and then use maybe GCC to compile now the generated C code to a binary output. So let me switch to a tool called AST Explorer just to show. Should be AST Explorer. Yeah, so it should be the first one, astexplorer.net. And the reason I wanted to show this is just to show you, like, if you do 1 plus 1. So 1 plus 1 is an expression that should evaluate to 2. So what you're supposed to do is to convert this expression from 1 being a number, plus being an operator, and then 1 being another number. So we should convert it to something similar to this, whereby you have an expression statement having, I think if you select here, yeah, you have the number 1, and then you have the operator plus, and then you also have the other one. Just click on it. The other one is, yeah. So you are generating something like an abstract syntax tree of the expression itself. And then once we have this, we can now convert it now into maybe C code, or even compile it maybe using C++, or just evaluate it on the runtime using our own interpreter. So with that out of the way, let me switch to my editor. I'll be working with the Z editor, so it has no file so far. So inside here, we need to create a couple of files, and for this first video, we'll be able to do the REPL read evaluation print loop. And then our second video will be doing the Lexer itself. Our third video will focus on the parser and the AST stuff. And then in our fourth video, we'll be focusing more on building the interpreter part of it, which is very simple once you have the AST. And then in our future videos, we'll now look at adding more functionality, because we'll be focusing right now on the primitive functionality, that is being able to lex and tokenize and pass numbers, strings, the basic operators like add, minus, divide, multiply. Then we'll also look at other things. Maybe you can add now comparators later, and maybe some unary operators once we have finished the first run through from the Lexer to the interpreter. So to get us started, I will create a new folder, and I've just called it expression evaluator as it is here, as you can see. I will add a new folder, and I will just call it src to hold my source files. Inside this src, I will add a new file called main.cpp. And this is what will be having our main entry point into the whole application. So under src, I will also create a new folder. Let me call the folder front end, and then I will call another folder. Let me just call it backend. So under front end, let me create a new file, and I will call it lexer.cpp. Similarly, I'll add a new file called parser.cpp. This is basically how we're going to be laying out our project. And then thirdly, we'll have the ast.cpp. I think that should be it for use case. We'll be working mostly with the inc.h files and the .cpp files. So I will come back here and add a new folder. I'll just call it includes. And since I will add a new folder, same to, let me just call it eval. And then under the same folder, I'll add a new folder called frontend for now. And then there I can now add a new file. Let me start with the lexer.h. Similarly, I'll add a new file, parser.h. And then lastly, ast.h. So all this will be in our subsequent videos. We'll be looking at how to populate them with functionality, such that every subsequent video will build on top of the previous work we have done. And at the end of the full cycle, we'll be having a full working scripting language. I think I will add also a new file under here, and I will just call it utils.c.h. And this will just hold some utility functions we need to work with as we do all this kind of thing. So let's come back to our main.cpp. Let me just do a hello world as usual. Just I'll do, let's do include, do iostream.h or iostream. I will do the int main, and then we just do std cout. Hello world. So this is the usual hello world, just to ensure that everything is working as expected. You can return or fail to, which or both is fine in C++. And then don't forget to save our work. And then to compile our work, I'm running this in Linux, in Fedora. And so you can just do G++ and then -o out. And then we'll pass in our source file as src, and that is main.cpp. And so we have a binary file called out, so I can basically run it by just doing here out, and we have hello world. So because we'll be having more files being added as we go along and adding more functionality, it's a good practice to use a better build generator system. And for that, let me add a CMake file into this project. So add new file. I think it's supposed to call CMake list.txt. I think it's supposed to be CMake lists, not list. So rename that. And for this, we need to do CMake minimum required. So this is just the normal boilerplate for any CMake project. So I will just get it and then we'll pick it up from there. Good. So this is our CMake file. Basically, we'll be working with a version 3.22 and above. And then we can just set our version to 0.1, even to 0.0. For C++, we'll be working with C++ 20 because there are some features beyond C++ 20 I'll be working with. Our executable will just be called Evaluate. And then I've just added the main.cpp file. So with that in, we can save our file. And then to build our project, I just need to make a build directory. I'll call it mkb build. I'll cd into build, and then I can do cmake in our previous directory. And then I will just do make. Good. And if you check our current directory, we have now this binary called xpr-eval. And so I can just write it by doing that way. We still get hello world. But now once we have CMake, it's much easier to kind of configure a project and work with it much more efficiently. Good. So with that out of the way, let's now get to building our first part of this video, which is making the REPL. So if you're not familiar with the REPL, so it's a read, evaluate, print loop, and this will run infinitely. So since I said we'll be working with a subset of a scripting language, so the user will be kind of, you and I will be inputting the commands we need to evaluate, and it will evaluate, give us the response, and move on like that. It's similar if you use tools like MATLAB. MATLAB will always give you that REPL, similar to Python. So if I open the Python command here, it gives you this command prompt. You can now maybe type anything, like you can do print, and once you execute, it gives you the response. The interpreter actually evaluates your commands, gives you a response, and then it prompts you for another different command. So we should kind of be doing a similar thing. So let me exit from this. Let me clear my terminal. So with that, for what of course we need to do is to have infinite running loop. So for that purpose, I will just remove that, and I will just do here while true, and then inside here, so we need to prompt the user to give us a command. So just let's use like what you have just seen for Python by using 3 carets, and then next we need to ask the user for, we need to get the input from the user, so we need to get a whole line from the user. So we'll be storing the user input into a string. Let's just call it input, and then let's get the user input by doing std getLine, and getLine expects what you'll be working with. You'll be working with std cin, and then the value will be stored in that. Good. So just for us to see what you have got from the user, we'll just do here std cout as well. I'll just do input, and then I will add a new line at the end as well. So with that, let's run our, let me do cmake build, and then I will still run our binary as usual, And then now we can type in commands like that. You can even do A plus B. So basically we are getting the user input and printing it out. Now there are some commands we need to kind of put them in. One of them is exiting from this REPL. And to do that, we need to check the user input. So I will add an if condition here to check if user input, if the input is equal to, maybe just to exit. So we'll break out of this loop, as simple as that. If it's not equal to the exit, then let's pass the string now into our Lexer for tokenization, and then next into our parser, and finally we'll be able to do the interpreter once we have passed all these cycles. I hope you've enjoyed this part of the video. So we have taken time to set up our project layout and the REPL. So in our next video, we'll be working now on tokenization and building the Lexer class from start to finish. See you in the next video. Bye.